Wind speed, or wind flow velocity, is a fundamental atmospheric rate. Wind speed is caused by air moving from high pressure to low pressure, usually due to changes in temperature. Wind speed affects weather forecasting, aircraft and maritime operations, construction projects, growth and metabolism rate of many plant species, and countless other implications. Wind speed is now commonly measured with an anemometer, but can also be classified using the older Beaufort scale, which is based on people's observation of specifically defined wind effects. Factors affecting wind speed. Wind speed is affected by a number of factors and situations, operating on varying scales. These include the pressure gradient, Rossby waves and jet streams, and local weather conditions. There are also links to be found between wind speed and wind direction, notably with the pressure gradient and surfaces over which the air is found. Pressure gradient is a term to describe the difference in air pressure between 2 points in the atmosphere or on the surface of the Earth. It is vital to wind speed, because the greater the difference in pressure, the faster the wind flows to balance out the variation. The pressure gradient, when combined with the Coriolis effect and friction, also influences wind direction. Rossby waves are strong winds in the upper troposphere. These operate on a global scale and move from west to east. The Rossby waves are themselves a different wind speed from what we experience in the lower troposphere. Local weather conditions play a key role in influencing wind speed, as the formation of hurricanes, monsoons and cyclones as freak weather conditions can drastically affect the flow velocity of the wind. Highest speed. The fastest wind speed not related to tornadoes ever recorded was during the passage of Tropical Cyclone Olivia on the 10th of April 1996. An automatic weather station on Barrow Island, Australia, registered a maximum wind gust of 408 km per hour. The wind gust was evaluated by the WMO evaluation panel, who found that the anemometer was mechanically sound and the gust was within statistical probability, and ratified the measurement in 2010. The anemometer was mounted 10 meters above ground level. During the cyclone, several extreme gusts of greater than 300 km per hour were recorded, with a maximum 5-minute mean speed of 176 km per hour. The extreme gust factor was in the order of 2.27–2.75 times the mean wind speed. The pattern and scales of the gusts suggests that a massive vortex was embedded in the already strong eye wall of the cyclone. The now second highest surface wind speed ever officially recorded is 372 km per hour at the Mount Washington Observatory, 6,288 feet (-1,917 meters) above sea level in the U.S. on the 12th of April 1934, using a heated anemometer. The anemometer, specifically designed for use on Mount Washington, was later tested by the U.S. National Weather Bureau and confirmed to be accurate. Wind speeds within certain atmospheric phenomena may greatly exceed these values but have never been accurately measured. The direct measurement of the wind speeds in tornadoes are rarely done, as the violent wind would destroy the instruments. Another method of estimating is to use Doppler on wheels to sense the wind speeds remotely. The figure of 486 km per hour during the 1999 Bridge Creek Moore tornado in Oklahoma on May 3, 1999 is often quoted as the highest surface wind speed. However, another figure of 318 miles per hour has also been quoted for the same tornado. Yet another number used by the Center for Severe Weather Research for that measurement is 302 plus or minus 20 miles per hour. However, speeds measured by Doppler radar are not considered official records. Design of structures. Wind speed is a common factor in the design of structures and buildings around the world. The wind speed is often the governing factor in the lateral design of a structure and is used by professional engineers and designers. In the United States, The wind speed used in design is often referred to as a 3-second gust, which is the highest sustained gust over a 3-second period, having a probability of being exceeded per year of 1 in 50. This design wind speed is accepted by most building codes in the United States and often governs the lateral design of buildings and structures. In Canada, reference wind pressures are used in design and are based on the mean hourly wind speed having a probability of being exceeded per year of 1 in 50. The reference wind pressure is calculated in pascals using the following equation. Q equals PV ** 2, where P is the air density in kilogram per meter * 3 and V is wind speed in meter per second. Historically, wind speeds have been reported with a variety of averaging times which designers may have to take into account to convert wind speeds from one averaging time to another. The Durst Curve was developed, which defines the relation between probable maximum wind speed averaged over t seconds, v, and mean wind speed over 1 hour, v.